Good morning, Namaskar. Good morning, dear friends. This is Ina Suraj Singh speaking from Bharat, India on this day, 24th April 24th, 2021, Saturday. Pertinent quality system, quality and quality issues within topic civil field engineering, designs, construction, methods, contracts, EPC, AnnexSL, organizations, communications, coordination, quantity, quality, and why should we be behind quality of concrete, standard materials, and concrete in every respect. This talk is in continuation to previous talks. Quality is lead topic in these talks because quality means life. If you are living without quality, you too practically do not feel happy, but maybe you are forced to be without quality. That is not in your control sometimes. Even sometimes you are not happy to go without quality, but you are forced, we are forced so to do without being any other alternative. Sometimes we have to do something we do not want to do, but because we have to survive, and you can say we are compelled to do that, we do it. That point is worrisome, but there is no way out of that. We have certificates of all sorts, as I showed. We have certificates of all sorts, like this high profile certificates, this high profile certificate, and we claim that we are, but we are not. And we claim that we have certain roles in life, we dispose those roles, but should we or do we? And of course structures and buildings and all that. This goes on and on, on and on, on and on, on and on, on and on. And like this, life keeps on moving on tracks of quality or no quality. That is different aspect of life. When I say quality and when I say designs, and of course construction, so quality, design, construction. You think quality is available only in construction, or it should be available in construction, or it should be part of our life? Construction, methods, time, performance. Methods, expressed detail, format for performance. Time, unchangeable. Cost, it may vary. Risks can be and must be foreseen. Reliability requires to be achieved. We can say safety is a must, serviceability is a must, durability is a must, and on top of that, analysis of everything and assembly or so-called synthesis of everything is a must. And thinking is answer to every problem. Thinking is an answer to every problem, and a group of thinking on solutions based on those thinking, which are called contemplation, and ultimately applications of all solutions or finding solutions through applications. We define engineering. Engineering is theory, engineering is reality, engineering is work, engineering is to be busy in thoughts, to be busy in real justified work. Engineering is never unjustified, and if we think is unjustified, it's not engineering, neither it is science. Quality is a group actually. We used to think if we construction should be in quality. I say that is quality control. Quality is master. Quality is doctorate. Quality is respiration. Quality is soul. Quality is a strength. Quality is a requirement. Quality is a domination. Nature is full of quality. If there is no quality in nature, if this element is missing, nature fails, but nature never fails. This means nature means quality system or systems containing qualities. Nature equal to quality system equal to quality. You can consider anything, whatever nature is working with. Everything is quality based. Without that, nothing can move. We impurify that as human. We feed impurities into purity of nature and make it substandard, and then blame also. Quality is different. You can take example of trees. You can take example of whatever is available in nature. You can take example of earth itself, skies, sun, solar system, and our bodies. Our body, human body, or some other body means animal's body or whatever body, all are perfect. Respective designs and relevant construction and consequently performance of all these machines. I am calling machines because not of physical machines, because of mechanism that works around this. Human being is perfect quality answer. Perfect quality answer because human is performing. Human performs since birth and performs till leaves this body. This is perfect example of quality. If human maintains everything okay, it works. This machine works. Yes, there are sometimes sickness with this machine, and that sickness is taken care of by health system. But it does not stop. Even during surgical operation, body does not stop working. It works continuously. All systems within body work continuously without any problem, even though our brain does not feel that. It is strange that body works and it is repaired same time. It happens with machines. No, machines have to be stopped during repair. That's the difference. Human is a perfect example of working quality, designed quality, construction quality, performance quality. Can't we learn from our body functioning? Our body means our physical body plus it's having certain current. That current which we can't define in physical terms, but that current works throughout life. If you count seconds in your life, you will find very big figure, because in 1 minute there are 60 seconds and in 1 hour there are 3600 seconds. You can say how many seconds in 24 hours and how many seconds you have passed through your life. But in those seconds you never stopped. Yes, you may hold your breath for moments, maybe, but body keeps working, it doesn't stop. This point we have to think about, and we have to contemplate about that. If you think that point, we can understand what actually God wants everybody to do. This machine is not built by me, neither by you. This machine, which is called human body, is standard one, and there is no defect in that in production. And this machine is owned by that power which we do not know. We can assume in terms of faith. But that engineer is sitting there, who is a field designer, who is concept designer, who has complete feasibility report, who is having complete design details of both body and soul, who initiates the software of soul and controls all time, updates it, and we continue to enjoy this journey on earth. This journey may be called engineering journey, this journey may be called design journey, this journey may be called whatever, by whatever name, but this is real journey where all kinds of actions affect all kinds of actions. If you think you do something, yes, thinking is doing itself. Thinking is such a journey which is very fast. Thinking is just a journey that no flight can match, no spacecraft can match. It's such a fast journey, but we can't see that. Mind is so strong because mind is moved by that power, that soul, which is root of life. We use electrical energy to operate machines. We use some other energy to operate all systems. And we have God-given soul energy that helps our body, that operates our body and controls it. Soul power, soul mechanism is still unknown. Nobody can claim till now how soul functions, how soul works. S-O-U-L, soul. It's a great word which we don't recognize yet. We feel that we have not seen it in engineering terms, in medical terms, in physical terms. We have not seen. Doctor knows about this body, all parts of body, but doctor does not know how these operate. Medically they can answer, but soul-wise, no doctor can answer. This very, very complicated point we have to understand, think and realize and analyze. Analysis can be done only in thoughts. It can be done only in thoughts for every part of body. It can be done for whole nature. Analyze, if you conduct analysis of something, there is no limit. You can, we can, I can find answer to those problems. Of course, that is imaginary, because it is not seen material, it is not seen element, but it is very powerful. Just like we cannot see our respiration system, our breathing system, but we know that we breathe. Machines can tell your breathing status. Equipment can tell our breathing status. Equipment can tell that we are living by whatever references to pulses, rates, blood pressure, heart working, mind working. Based on those relations, doctor certifies that person is dead or alive. But doctor cannot justify how could this respiration stop? How could this soul stop? No doctor can, no medical word can answer to this question. This means complete quality is unknown. If we can't analyze, we can analyze, but we cannot synthesize that. Doctor, medical world can analyze your body, everything it can do by testing, but it can't tell answer. Can some doctor assemble this body? Answer is no. Because it is not in ambit of doctor or medical world that body can be revived. And body and doctor also cannot tell you. What does that mean? What does that mean? No one can answer this question, because there is no meaning until we know that, we understand that. We simply say, these test reports tell there is nothing in this. Breath has stopped, heart has stopped, there is multi-organ failure like this or like that. And body ceases functioning. You can imagine by this what cost we have with us. Without payment, we have this value that God has given us. Risks and reliability both are there. If my body is healthy, it's risk-free, it works well, and it's reliable. That's very important point. But we do not know method about using which method this body was constructed. It's really very interesting to know how this body is constructed, using which design and under what quality system, which we can't know. I'm just giving you this based on only my thoughts of life. It's only based on thinking. Otherwise, I can't tell you. It's very important point. In engineering world, lot has happened in all branches of engineering that we name. Lot has happened. When I was too small, young, I did not know what engineering was. But I knew that there were few engineering that time. Usually, engineer was understood to be a person who produces houses or machines or deals with electrical power. There were these three engineerings: electrical, mechanical, and civil. Other engineerings names were not known in those days. Later on came automobile engineering, television engineering, we used to call TV engineer, mechanic, all that type. But life was known through buildings, frankly speaking. Buildings or roads, railways, these were main points, of course, railway stations, airports for those who were rich, or ship. These were major points, major destinations through which engineering was known. Engineer was generally understood to be that person who knows how to construct building. Machines and electrical were not that type of engineering in those days because the world were not very much mechanized. Electrical energy was not that much dominating, and all agricultural work was done through ordinary means. So those disciplines, those branches of engineering did not develop well. We have to realize this picture in our mind. If you compare development now to that, designs, constructions, methods have come in, and we have changed entire world. We should not say we have changed entire world, because world has changed itself, and we have different rules in life. We talk of those people who have dedicated their life to building, to development of world, and site engineer is one of those. Site engineer is one of those. Design engineer is one of those. That's why I just want to share role of a site engineer. Subject is different. I say, prior to deliberating role of a site engineer on whatever job, we should know actually what is site engineer. Is it same that we use term, or it's different? Just like we say engineer and engineering. What actually is site engineer? I can say, you may say a person who works on site is site engineer. You may say a person who develops is site engineer. Yes, it can be. But I think site engineering indicates a chain of various engineering works. Various engineering works. Descriptions belonging to all disciplines, starting from bidding stage or tender stage to handing over and maintenance stage of delivered building or structure or project. It's like workshop. You can say floor manager, floor engineer, who takes responsibility of completing all activities of floor work. You may say that site means a place. That's right, site means a place. We can with complete competency say that Site is a location, a piece of land, a place. That's right. This means where work is done, that is site. Generally, where work is done, that is site. But site does not apply to a place where work is done and delivery from there to somewhere else. I think that is not called site. Site means where work is done and delivered to same place. Where work is done and delivered to other places. Well, I think that's called work area, workshop, or factory, where materials are procured and assembled to factual world. That is called work, and delivery is made to some other place. That could be difference between site. Site is permanence, and where work is done and delivered there itself, and it can't be taken to somewhere else. So I think value of site is more permanent than value of work. The work is done on site means just trying to say meaning of site is root itself. Just like a tree is grown and it does not move elsewhere. Once it is grown, it stays there for centuries to come or decades to come until it is thrown away or derooted, uprooted by storm or by some other encountering on this. So site engineering means it's very different world. Site engineering is a product of design engineering. It's a product of earth engineering. It's a product of soil engineering. It's a product, you can say, air engineering, solar engineering. It's a product of natural engineering. You may say that. Because we don't count those when we work on site. All these agencies work, but we do not classify or group them into our work. We never say in methods or wherever we shall use air and humidity for this work, or we shall use sun rays. We never count those agencies which completely and in full respect add their values to our work and to ourselves. If I don't get sun rays, I don't get air to respirate, I don't have effect of nature onto my body, I can't work on site. That's also true. And it applies to all. Since that unknown element, of course it's known, but unknown in that construction, in that site activity, we don't value because it's free of cost. And if something is free of cost, we actually don't value that. What is small consideration? It is, believe me, it's very small consideration, but it is unavoidable. If I can't stand on site or work on site, and others can't stand on site and work on site, certainly there will be no site at all, there will be no work at all. Right? There will be no work at all. It's like a field, like agricultural field. Agriculture is also a part of engineering now. It's a full branch of developed engineering. There was a time when we did not consider agriculture as engineering. But if there is no crop, if there is no fertilizing, if there is no work here, what shall be that field having nothing but desert? It shall be a forest. So what I say, site engineering indicates a chain of various engineering works, descriptions belonging to all disciplines, starting from tender stage to handing over stage and maintenance stage of delivered building or structure or project. Now we construct something, and that construction is not alone civil construction. It is supported by, it is interrelated by It is intercoordinated among all known disciplines in modern construction. Hardly certain disciplines left which you don't use, and generally on every because a project or every structure, all all groups, all engineering branches contribute their roles partly or fully. Just like without mechanical engineering, without use of machines, without use of electrical power, without use of, you can say, other powers like security system, like access control system, and like whatever else, sewer system, water system, solar system, electronics, IT, even agriculture for landscapes, soft landscapes. I'm sure no field is left, transportation of course, no field is left that doesn't contribute to our structures in current scenario. So site engineering means not civil engineering itself. Civil engineering is root, of course, civil engineering is basics of that. But civil engineering requires to be fully supported by all other branches of engineering. If you just construct one building successfully and landscape is not done, you will find that surrounding is looking like a desert. It doesn't look like something is built. Yes, some structure stands, but when that soft landscape comes to action, means somewhere you may say plantation, bushes, trees, all these are to be done. Even trees are to be tree pits are to be excavated, and using sweet soil we can grow trees, we can plant, we can just root in trees, and also we have to fix grass for grass development, grass growing, foot about 30 1 feet or 300 mm depth of soil, seed soil for purpose of grass. Likewise, we design all plants in consonance to what is environment there. So that agriculture also comes into play. It may be called horticulture rather than agriculture, but it's the same thing. Principle is same. So we can say site engineering is not just civil engineering, it's complex of all engineering, may say, complex of all engineering. I have to understand this point very differently. And then after understanding that point, we can say, what does engineering mean? How do we add up engineering to one engineering, and that is called field engineering, or that is called real physical output engineering. What is that engineering which gives us a result in such a professional fashion? Means there are so many engineering involved in that. Site engineering, and that site engineering also imports workshop engineering, or you may say factory engineering, or you may say industrial engineering. This import all outputs from all other engineering to one site, and that's what I say it is. क्या हो रहा है? अच्छा, बताता हूँ. 4 बजे हैं अभी, 4 सवा 4. So when we talk of this, when we talk of definition of engineering, when we talk of and contemplate on definition of engineering, site engineering, we have to change our mindset now, because it's not concentration of engineering, but it's for collection of engineering. If you just analyze cost wise, if you classify cost wise, I will not find in very advanced projects like in Middle East, in Gulf countries. Element of structure in buildings is not even 50% in some cases. I'll analyze that. 30 to 25%, in some cases 25%, in some cases 40%. Cost goes to structural engineering, not more than that. 18% cost goes to mechanical engineering, probably same cost to electrical engineering, and also machines cost a lot, decoration work costs a lot, finishing items cost a lot. So if you just compare in that 100, structure doesn't cost. Of course, it is major item, and it's item without which nothing goes on. But cost-wise, it is not that much comparatively. But time-wise, it's very important. So we can't simply say that it's a structural project. You can't simply say nowadays that such coordinated projects where buildings are actually constructed, buildings or other structures which have certain finishings with them. Buildings do have finishings without which it can't work. Buildings do have services without which it can't work. So building project is no more a structural project itself. It's a project. It's it's a product of different nature now. A complex engineered project it is. There is contribution by all branches of engineering in that project. This means it's not alone civil engineer or electrical engineer or mechanical engineer, but also all other engineers who extend their expertise onto such projects, such proposals come into play and come into command. So our roles are different now. It may be construction end, or it may be supervision end. Roles change and sequence of roles form. If one time there is role of a civil engineer, same time there is role of other engineer. That has changed scenario. Means you cannot say that only one person can do that, because expertise is required, and that expertise from every field is required. Certainly there was a time when one engineer was available and that engineer could do structural work, brick work, stone work, or you can say timber work, wood work, and also plumbing work, sewer line, water line, whatever was required. But now even sewer line and water line have gone to both mechanical engineers role and civil engineers role. Generally, internationally, sewer line, water line, pipe work, this and that come under ambit of mechanical world, like structural engineering itself. Structural steel engineering erection, that comes into mechanical world, and of production, of course. There is an overlapping of these disciplines, but supervision is done by many engineers on same building, many different disciplines engineers, and same thing, construction itself. As an engineer, of course, everybody is qualified in considerable branch of engineering. Very lengthy syllabuses, very lengthy programs to learn all engineering. But fact remains that totality is absent from education. Totality of production. When you consider a building delivered, produced and occupied, being used, building cannot be taken out and delivered to someone else. It remains there. And it's a product of multidiscipline. Multidiscipline product is building. Multidiscipline product. We can't deny this fact. A flyover cannot be called multidisciplinary because services role is very limited there. Electrification, I think not more than that. Even you can say some transport system, road project or railway, 2 or 3 engineers come into play. But it's only building of modern requirement, modern functioning. This building speaks clearly. I am kid of many fathers. I am kid of many fathers, including natural fathers. Because whoever fathers are, those fathers are not independent. Those fathers use input by natural product, steel, plastic, stones, aggregates, water, soil, or whatever else are all from nature. Though we say we have nuclear reactor, we have atomic action, they have nuclear reaction, we are doing this and we are doing that. We are generating electricity by this uranium enrichment, produced atomic work. We say so, we claim so. But if there is no uranium, there is no thorium, what shall that reactor do? And if there is no concrete, what shall that reactor do? Its gamma rays to pass through. What shall that reactor do? So much quantity of RCC is used in those buildings, in those reactor buildings. Question arises. So that is different kind of service. After all, that's a building. Plants, if you see our plants, facilities plant I used to call them, or industrial plants or oil plants, oil related plants, or powerhouses plants, electrical generating plants, or you can say chemical plants, chemical processing plants. All those plants are a collection of all engineering disciplines. All engineering disciplines. We must value them accordingly. If suppose you have not seen any plant in your lifetime, no problem, you can go and see, or you can see by searching on searching on Google. And if you think of that, how much pipe has been used in that plant, how much structure still has been used in those plants, how many buildings are available in those plants, how many foundations are in those plants, what's value of landscape there, means it's buildings there, it's buildings of different classes, it's building administration building, warehouse building, supporting buildings like amenities, it's buildings of controls building, and also there may be different types of electrical buildings. There could be various work sheds and compressor foundations and vessel foundations, and many more mechanical foundations. Likewise, you'll find there's water collection bodies, water reservoir bodies, pipe work foundations, and pipe work platforms, overheads, bridges. Means there's so much. Hard landscape, soft landscape, and underground utilities. Means internal road work. In some cases, trains also. It's like something, you can say, a network, physical network, not electronic network. Physical network where work is done. That work cannot be done otherwise. And it's done round clock, means it never stops. It stops only for shutdown and then part 2. There are chances of fire explosion, there are chances of evaporation, chance of vaporization in environment all time. And people working there at risk. Top level safety HSC is arranged, and even then there's explosion sometimes. So in those kind of projects which are having all the strife, this we can relate to buildings also, because everything is building after all. Shed is a building, foundation is a part of building, machines foundations are, we can say, machines tops are supporting tops of parts of building structures. Soil exists everywhere, so we can't differentiate that from our buildings I'm talking of. As I'm talking of pure buildings, means residential buildings or commercial buildings or institutional buildings or this. But buildings do remain everywhere. There are more dangerous buildings like blast resistant building and blast resilience building and non-blast buildings. Electrical buildings are also very, very important one. As control buildings, I can say, all these work together to add their roles to such kind of plant's performance. We have to be very, very clear. So responsibilities, of course, do change, and we have to understand those responsibilities here. What actually changes? We call them sometimes non-plant buildings. We sometimes call them plant buildings. It happens. It happens. And no one can change it. Means it's not one, not two, but many roles are involved in those buildings. Sorry. No, I'm just saying supervision role and contractual engineer role, that is, and also I'm saying construction end. Certainly there are 2 points in any work. One is construction, other one is supervision. Of course, on top of this, or you can say before this, prior to construction, we have to design every project, without which project cannot be started. That design, of course, is a role of engineer. It's complete role of engineer, but here the design is to be implemented on sites, but we call it design engineering work. Design engineering means it's a pre-work of site engineering, but it's a part of site engineering itself, because without this site engineering cannot go. You may say design is a lead engineering of site engineering. Design leads how to work on site, and without designs we can't do anything. That's also true. So design engineering is a role of site engineering. It's a lead role, site engineering lead role, as well as lead role of supervision engineering. All are related. We have to think this way now, not simply that I'm a design engineer, so I'm independent of site engineering. No, it's not. It is amalgamation of engineering and design. Is worth, it's important, it's significant, it's a command, and it must be given that value. It's not simply production of designs or drawings or specifications. It's really a requirement how site shall move, and design is director of that. If design is not complied with, you cannot say the project has been done, has been over. We have to think that way. We cannot simply stay on our own, that I'm not concerned. You are design engineer, and design cannot say I'm not concerned, you are site engineer. Even though design is delivered to sites in whatever way, in whatever contract, that design requires to be fulfilled, that design requires to be implemented spiritually, soul-wise, perfectly. Only then that design works. And generally it should be done, and it is done, because design, if it is not done, then it is not done. Design is done, and it is 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 done. Desig has its own considerations. When you design, you have to use all those formula, procedures, contemplations, assumptions, codes, practices, conventions. You have to use all those, without which, if you miss them, you don't justice. You don't justice. You don't justice on your own work, and you can say you miss something. And design gives alternatives. Designs also do have options, and keeping everything well, a person who designs, he tries to come into requirement contact. The designer keeps himself abreast and tries to bring in best possible solution, and that possible solution is produced on design drawings or within specifications. Those solutions must be transformed to real world, real project. This means even if we don't like to accept, or we may try to keep ourselves independent, it won't work. Both are linked. Works design and works engineering, both are related. Of course, designer replaced works, engineer is also replaced. When I say works engineer means site engineer, and I say work designer means project designer. Both can be replaced, but whatever is done, that cannot be replaced. Persons may change, but work cannot change. Construction is construction based on designs and supervision, which is obliged to make sure whatever I have designed and whatever expected to be executed into would be done. So there's a higher responsibility of doing right work on shoulders of those who work on sites. They are very responsible professionals, and if they think so that they can deliver, they can deliver more than required, more than expectation. I think I respect those engineers who have determined, or who would determine to do best of requirements. That's what engineering desires. That's what engineering thinks so. That's the engineer thinks so. If whatever knowledge I have, whatever experience I have, and whatever best can I think, I should work that way. In that way to work and deliver. That is called best work, best thinking, best contemplation. Of course, everybody has limited value, limited knowledge, but that doesn't mean that we can't think so. So what I say, site engineering is complete different engineering nowadays. You may say it's real production engineering. It's really physical engineering based on contemplative design engineering. Design engineering is very difficult. It's indeed. But site engineering is also very difficult, because something is difficult, there's a difficult design work. And that difficult work is to be given shape by world of site engineering, and that is element by element, level by level, area by area we have to do. Though it was thought collectively in our designs in initial. Okay, we thought that model which is now being constructed. At one time it was under consideration of designs, and how difficult it was to design. It's not simply a copy. We have to think of in three-dimensional, all directions, how this behaves. That building is very difficult, and when you have to do that, you have to construct that also in same spirit or super spirit. So site engineering cannot be simply called site engineering. It is actually professional engineering for construction. Professional engineering where your total body, total soul, total physical body are involved. Your knowledge is involved. Your determination is involved. And that is involved not only physically but qualitatively. Qualitatively we have to do that. Qualitatively. When we talk of supervision, what does that mean? Supervision just means that you do same which you did in past. Supervise that. Is that supervision? Or construction plus supervision? Which is supervision? To my understanding, supervision is construction plus supervision. Not just supervision that I go and check some work. See, we are not kids. A person who constructs is also qualified. Only difference is that person is based on site and I am not based on site. I am a supervisor or consultant or a designer. I base in my designs. That's the only difference. But objective or focus of both is same, that this project be delivered in a best possible manner. I consider supervision, first supervisor should know in all respects about construction engineering. Means supervisor must know much better than construction person knows. It's not simply I have come here, I'm a supervisor, you show me, I'll check, I'll pass it or I reject it and go. It's not that. Yes, of course, supervisor can't be present on site for so long duration for same thing, because every supervisor is have many projects where one goes and approves all these works done or to be done. Supervision, I think, is more responsible than site prosecutor or site representative, we call by whatever name, site agent or project engineer or whatever. That role is not an ordinary role. That role is very different. We have to keep in mind that role. Role of designer and role of site, both are together. Of course, timing is different. We should not forget there might be some conception in mind of the designer while working out design. Those points can't be produced on paper, can't be expressed on paper. But whatever is expressed there by the designer, that's one part. And what is left, that's also one part. We have to be pretty clear about that. But after all, it is material, it is cost, it's natural product, it's human resources or else that's going to that project, that product. Why not to be then very serious about this? Why not to be serious about this? Question is that. Why you say this person is lower, this person is higher, when all persons work to produce that work, which is quality work or non-quality work? If we do everything in supervision, everything in site work, everything else is required, a product must be quality one. That is natural. But still, why don't you accept that fact? Oh no, this is not my job. I'm responsible for this, I'm not responsible for that. Why do we run away from that responsibility? Stating just that, oh no, this is beyond my control. Why is beyond control? What is beyond control? Why can we control? These points do value. What is beyond control? Nothing is beyond control. So site engineering, you can say, equal sum of all engineerings on works. And this means descriptions belonging to all disciplines work together while site works. Supervision is also same, means you are supposed to know construction activities, only then you can say yes, that's right. You may know better than, of course, site guy, because you are having more experience, and maybe that site person, budding one, or not having that much experience, that as supervisor engineer, a supervision engineer you have, you are a supervision engineer, not a surveillance engineer, remember. There is a difference. When surveillance comes into picture, that is not that high responsibility. But when supervision comes into picture, that is absolute responsibility. Of course, in work, not in contract. I'm not talking of contract here. I'm talking of responsible conduct, responsible behavior, which is very important part of life. If I understand what is my responsibility and what is the responsibility of others, and we can enhance our responsibility, we enlarge that, keeping abreast, project value. It is, of course, responsibilities we define ourselves. Nobody else defines. Therefore, that responsibility can be enlarged in interest of work. As supervisor, or can say as higher responsibility person, it's my duty to make sure that work, whatever we do or contractor does, must be more than in quality, enriched and delivered than what we expect for. But does it happen? If that could be so easy, there should be no such problem in quality. There should be no such problem in any can say at any level of quality. But it doesn't happen. This doesn't happen, and that's point where we are weak. Quality production requires attention, requires concentration, requires constant supervision and constant execution. But time is a factor here. Even if we have adequate number of supervisors on site, adequate number of site prosecutors who actually work on site for complete material and activities, we have adequate number. Even then, we are human beings. We are human beings, and we have tendency to loosen, to relax, and we are not like machines that full-time work second by second. When I say supervision, what does it mean? It means I am an engineer who has to make sure whatever someone else does is acceptable. That's what I think. Means I am little competent. I am having some degree of competency to decide that whatever I get, whatever work is done, that is appropriate, that's all supervision means. This means if it's certified, though it's not my responsibility, yet I can say, yes, this person has done, all this work is done on site, and that complies with all requirements, means activity, whatever is done, it complies with definitions, with extension of definitions, that's included in documents, or you can say drawings and specifications. That's what I make sure, or if it's not given, it has been done according to good or the prevailing good industrial practice. And when I say that's my job to do like this, and I have to report this to my real supervisor, my absolute supervisor. I'm a relative supervisor, I'm delegated supervisor, but my original supervisor, who is responsible for this design, for this project, is responsible to make sure whatever is spent on this project is really brought back in terms of quality of work, quantity of work, to whom we generally call contractually engineer, and who is responsible for complete project, complete structure, complete use of that project, complete delivery of this project. So that's also supervision end, because ultimately that person has designed, and that person are responsible for design. That person supervises as well through either directly or through someone else. Doesn't make a difference. I'm not entitling here titles. I'm just trying to, titles are here. Someone is resident engineer, someone is engineer, someone is chief engineer. It depends on what type of, and designer. So engineer is called to, means when you say engineer in contractual terms, or in law terms, when I say engineer is understanding of in project terms, you may say, forget law terms, project terms means, because project is project, and that project says this is project engineer, means an engineer was responsible completely for this project, was responsible for designs, was responsible for supervision, for execution, a sum of everything, you can say, where accountability comes in. This is an engineer. And that engineer has many structures, resident engineer and down specialist, supporting that resident engineer. Likewise, that is hierarchy, depending on size of project and disciplines involved in. And same way you can say engineer is there, who may be called chief engineer, who may be called whatever, doesn't matter. And when you come to construction end, which is real end on which depends success of all engineers, success of all designs, success of best use of material, not to destroy its use, everything, and that's called construction end, or build up end. Construction actually is an indicator of success of designs, success of teamwork, success of money achievement, and construction is answer to all those problems, questions. And construction can defeat everything, and construction can bring victory to every activity. If bad quality is achieved, construction is destruction, you can say. If bad quality is achieved. Bad quality means bad supervision. Of course. If work is bad quality, means it's no good supervision. Simply. Otherwise, why should there be bad quality? It's proportional, directly proportional, this equation, that good supervision is proportional to good quality, and bad supervision is proportional to bad quality. It applies to construction also. Good construction is proportional to good quality, and bad construction is proportional to bad quality. Construction is very heavy already. I'm not talking heavy foundations. I'm saying construction is very heavy because it is done in weather conditions, all weather conditions. One who is involved in construction and real constructor who is, you will find that person very different. You will find that person's life is very different. But if a person is oriented to designs only, that person with little profile, higher education of course, and having different type of personality, not talking too much, but thinking too much, which is basic requirement of designer. But construction is very different because it's not one person. Design can be done by one person, but construction can't be done by one person. It's impossible, you can say. A person who's involved in construction, of course, is equally qualified, but experiences are different. Dynamism of thinking, dynamism of working, total dynamism, total strength, total aggression, etc., etc. All are necessary, all are required. Absence of one step means absence of many good steps in construction. Construction always means production. Construction always means production. Production not of parts but of whole. It's not done in one day, just like factories work for spare parts or for parts. It's done in years, in months, and same activity is produced with different quality, variance of quality, we can say, of course, within limits and tolerable. We must realize this fact. Construction is not done in same season. It covers many seasons. It covers many materials. It covers many standards. That's why it's not one way. Howsoever fast we do it, howsoever rapidly we do it, there's no one answer to construction. There are many answers and responses to construction. And many buildings are there, many structures are there. We have different constructions, different materials, different types of designs. Whatever we can say, after all, it's not simple. It's work of hundreds of hands and many minds, which results always in construction, good construction, bad construction. Here I'm not talking of titles what we give to such people. I'm talking of responsibilities. Just like we say on construction end, project manager, leader or engineer, downwards to all levels, up to foreman, supervisor, and charge hand, work in whatever construction contracting company. This destination are factually responsible for achievement of project construction execution. Engineer. An engineer who represents company, or organization on real site, actual site, and functionally reports to engineer's representative or resident engineer. I'm talking of that person who works on behalf of contractor. Certainly that person has to the site representative of contractor, and that person must report to representative of site. That person who is such high profile on behalf of contractor, that person can be called site agent or site in charge, depending on what's practice and what's requirement of contract. Term doesn't matter, responsibility matters. And generally, we call it responsible site engineer or site agent. So this means there are two responsible people. One is on contractor who is responsible, and on the other hand there is contractor's representative, your client's representative. That's called resident engineer, or we may call by whatever means. It's not necessary we call resident engineer there. It happens usually. It usually happens that we sometimes do not care about this, which we should. I don't know why we don't care, but we should care. After all, this question of money, this is question of expenditure, we should be worried about. We should be worried about everything. Role of all such professionals, as I said, are different, but focus, destiny is same, and that is good product of project, and project that lasts long. And because this is not one day project consumes months and years, and there are possibilities that people start boring in, and people start thinking, oh, I've done this work, no problem, I'll do it again. But they forget that slackening on such activities or leaving them relaxed leads everything to dustbin. So when there's abundance of quality system, abundance of safety system, people are not worried yet. Construction is very complicated nowadays, and most important is element of RCC, reinforcement concrete. You can say for accomplishing RCC, which is in foundation as well, and of course knowledge of existing soil formation strata, and below many stratas. This count a lot in implementation of such you can say requirements. Concrete is a material that can't be controlled chip by chip, stone by stone, or particle by particle. Reason we know, thunderstorm everywhere sometimes, floods everywhere sometimes, or even bombing by those who are against humanity. We have to realize this fact. We have to evaluate this fact. Cost, time are spent, and if quality is not achieved, what is value of being an engineer? There is no value of being an engineer. It is duty of site person to leave no stone unturned. No stone unturned while doing work and complying with requirement of designs. Best person is that who delivers more than expected. More than expected. Where design is useful more than it was before understanding. Purpose is that. For that purpose, various junior people are employed in construction, and also many people are employed in supervision, just to make sure that whatever activity is done, that is done according to standards requirements, according to new updates on practice or applications, and that's an important point. Now what QA system says? Quality system, it mandates that safety, engineering, planning, contracts, construction, supervision, selling, etc. All are done. But again, scrutiny is no answer. If you can't understand scrutiny, project is no answer if you don't know this project. Safety, when we say, it's not simply saying it is to be achieved. It is to be maintained. Because when we do safety, we talk of safety. We want safety during work, during involved persons going out and in, and during teachers working as. Now, safety, health, environment, and ergonomics, these are very important part on construction. So we can't expect in such position, just for formality's sake, provide one man and then sit in the office. Very extraordinary. Without safety, you can't do anything. Engineering can comes in next one, which would tell us what we should do. What have we to do? Here engineering means coordination. Engineering means just to make sure whatever details we have are constructible. Just to make that sure. Because clashes are always found. Clashes. And clashes don't work together. Because of many hands change during designs as well as during work, many hands change, many drawings are updated, or I can say are cleared. Many dates are given best possible answers. But that's not why. I have to say, safety, health and environment, very important part, without which you can't do work. Engineering is a type of, you can say, scrutiny part. Scrutiny, technical scrutiny, which means we have to make sure whatever details are given are applicable. These lead to application. And then planning, which is scheduling, in fact. Scheduling, bar chart or other formulas. It gives us an input about time and weather controls. When we consider planning, we must have complete picture of job we are going to do. If you don't have that picture in your mind, I think we can't do planning. Planning is not simply bar chart, no, or CPM, no. It's complete, you can say, it's complete analytical based knowledge. We should know what's going to be included on this job permanently. We should know what are details. We should know these details are worth to be executed. Therefore, planning is very different. You have to plan expectation of resources to be deployed. You have to plan about what is material required, which of specification is applicable, which is not. It's source of thinking, source of calculation. Then we can say contracts. Contracts is very complicated binding on each party. Then we can say contracts come into picture, which is a document that divides the responsibilities and scope. Divisions of responsibility, and based on those responsibilities, cost factor, time factor, usually call contract data, in which these responsible parameters work together rather than working on 20 or 30 parameters. Small parameters are reported. Now, this is called contracts, which is division of responsibility and payment. We will discuss it later on. Construction, which is ultimate destiny, and also surveying, quality, materials, administration. But construction involves all these. Construction involves all these, and that's beauty of construction. We should not be different on that. We should not say I'm not involved in construction. If you are not involved in construction, you probably are not involved in other areas like designs, like planning, like engineering, like contracts. You have to think very differently now. World has changed. You have to be a very different person. We have to. No way. And we are not different means we are defective. We must understand art. We must understand the science. Everybody cannot be same. We have to understand that part also. And people are normally intelligent equally or average, but there are people who are many times intelligent than those, sometimes not even average. So that's what we can say construction is all about. Nothing is solid in construction, everything is solid. Just like all batches of concrete are not same way all students anything I'm not saying. And this happens, we may say rightly or wrongly, but this happens. This point you have to understand very well. Well, I'll be back in a few minutes, and you have to can take, I said, what's that? Oh, I don't know where's it's phone gone. Site construction is really extraordinary understanding. If you understand this extraordinarily, we can get a lot. We can get many answers, many views on this. And here what we said, that we said something about this, and these are very important factors, considerations. We can see various level of engineers are involved in that, but my point is not that. It's different kind of consideration, a different kind of view. A QA system requires all these: safety, engineering, planning, contract, construction, surveying, quality, materials, administration, various stages, strong models, typical sections. On this, all these sections have pertinent detailed roles to act on projects. Roles are defined in project quality plans, and we have to discuss those roles in talk. Now we know that every project involves planning, mobilization, surveying. This is very important. Planning, mobilization, surveying, start, kick-off, construction, quality supervision, completion, maintenance. Planning. Now, planning has also got many meanings. Site planning we are talking of. We are not talking of national planning or international planning, or you can say budget planning or something. We are talking of site planning, construction planning, and that means mobilization exists, surveying, start, kick-off, construction. Construction is a very long process. Quality supervision, completion, maintenance, we can say all this. And earthquake is just title here because there's rules in that talks. It's site engineering coordination, and we can say site engineer means has no definite independent direct role, but indirect role to implement design, engineering, project decisions, to comply with quality systems, with strongly extended base support by all responsible discipline sections. It's a very important point. We can't go against that. Now, site quality plan, site safety plan must describe functionary as well as reporting roles of all responsible engineers on project. Site quality plan and site safety plan must describe functionary as well as reporting roles of all responsible engineers on project. Now let us say design review, which is our job of site as well. They are responsible engineers deployed on site. Review is first involvement to make sure that design specifications requirements have been included within design philosophy. Engineering design section does it. It doesn't mean we have to check design's theories or design's application analysis. It's not that. Design review doesn't mean that. Design review means a kind of study in which we have to make sure there's nothing left in this without which construction cannot be done. And of course, to make sure that it's acceptable in a way, you can say it may be structural steel, it may be RCC, or it may be whatever else. There's no problem in constructing that. No major problem is caused. It doesn't mean we are scrutiny or a proof surveying or proofreading. It's not that. It's a review, a coordination review, you can say, a coordination review. We're not going to check what the design has done. But to make sure we should not face any specific difficulty that can stop work, that can cause hindrance in pushing job. That's kind of study. Because we don't have details of designs with us. We don't have those stress analysis, and we are not interested in that as well. Of course, we have our foundation details and we have soil report. We can make sure, yes, this is okay, fine, in relevance to each other. But that's kind of different study, which doesn't which actually, you can say, experience can lead to that level. I don't say a fresh person comes from university and becomes site engineer, that person has that capacity, but person or experienced one who have done similar projects in past and varying nature of experience they have, they can understand, well, design looks fine, it looks working, it looks applicable for practice, it can be applied, and we don't find any major issues using these designs, and time may not be wasted. And if there is something, it's fine that if this is replaced by some other method or some other material, or for example say sizes of rebars can be changed, or overlapping can be changed to mechanical connectors, such type of such type of view can be presented, so that time of working, time of doing job is saved because time is very important factor, and that may also impact on cost. Now soil report is also available in many cases, which requires a thorough review through engineering section of site. If it is otherwise, site person who is responsible, he must have a copy and must have understanding of that report, and to make sure whatever site when excavation is done, how it looks. Does it look in same way as report available report says? It's to make sure that all recommendations included by soil or geotechnical engineer have been covered within design report. In case of whatever pinpointed observation, it should be brought to notice of designer through agreed procedures. So design review, also soil report review, both are very important. Design has direct relation to soil report as far as foundation is concerned, particularly foundation portion. And if soil report and site conditions are different, question must be raised. Sometimes it happens that soil engineer has not given proper attention. The site person knows there can be a lot of difference, and sometimes it is well done. Whatever happens, maybe there's a doubt, and we shall raise this doubt as site person to designer or to soil engineer and question. It's a part of coordination, it's not a part of domination. And also specified on design drawings, specific value of soil parameters adopted on design, those must be verified or confirmed prior to laying foundations. Or in case localized soil does not allow those design parameters, then question is raised and design be reconsidered. Now site engineer has to conduct this test in all major areas of site. Site engineer conduct means has to involve in that test with laboratory, and site quality engineer must involve for quality accuracy of test. Whatever variation from soil report must immediately be reported to soil laboratory and designer, and it must be supervisor responsibility or resident engineer to make sure that testing system complies with standard procedures. Now all materials are tested. Indeed, all materials according to specification requirements are tested to ensure that quality complies with requirement. Particularly reinforcing bar is an important item for purpose of procurement. Rightly and specifically, concrete tile mix must be carried out if it is not immediately available. If it's available, that can be considered, but in certain cases, in remote areas, concrete tile mix should be carried out. It takes time, of course, but once it is to be done, so that right quality required mix is produced to meet design requirement. Nowadays many projects have been done many data are available, those can be considered formally if it's a small project or we can't afford for trial mix. But if we can afford, we should do this. Otherwise, standards are available and we can go for them to adopt them. Issue of piling comes in. It should be done fully in compliance to specific design and test load requirement. Test loads, load tests, integrity tests, all must be rightly, satisfactorily conducted. Connections between pile cut-off level and pile cap should be rightly and satisfactorily made. And these piles tests must be conducted much in advance. Site engineer through engineering must make sure that all drawings contain right ductile detailing of reinforcement. In case of whatever detail missing, must raise immediately whatever query for confirmation. Arrangements must be indicated on typical standard drawings by designer. It's very significant for proposed materials to resist earthquake forces, which included materials should conform to standards without doing any adjustments. No compromise should be made in quality of these materials. Generally, it's RCC are often included on various buildings and it's certainly considered for designs. It's significant to produce concrete works with good quality, and no batch of concrete should be allowed to be poured unsupervised. No batch even. We know that every batch is different. Every batch of concrete is different. You have to keep that in mind. Though it's from same batching plant, but there can be variations, though it's within limits. But we must be sure of everything. It must be ensured that whatever precautions are required to be taken on site, to be adopted on site, should have been explained to all responsible skilled craftspersons as well as those who are leading at front. All requirements should be included on method statements explicitly. All detailed method statements should be approved prior to ongoing activities done. All requirements should be included on relevant method statements clearly. All detailed method statements should be approved ahead of every activity. All quality controls must be conducted during concrete pour. These may include slump test, air voids volumes, concrete temperature, concrete mixing, to concrete finishing time, and whatever else is required. All steel bars details must be produced in form of BBS prior to giving to fabrication. Whatever BBS you use, 8666 or 8866, BS, or past one BS 4466, or your own, whatever, depending on your choice, your work office, or easing your work practice, and that must be known to all fabricators. Now, prior to giving to fabrication, now these should meet requirements to avoid stress localizations that you have to decide. It's not necessary, you can't think on that. As far as practicable, overlap should be avoided. Rings or struts should be fixed in such a way that hooks to continue to on site as precautionary measures. It should be remembered that reinforcing bars during earthquake action time, change behavior drastically. Because force of earthquake doesn't come vertically alone, it acts in all directions. Bars provided with gravity loads start accepting horizontal shear, though it's not 1%, but maybe 0.25% of vertical load. Bars provided with gravity loads start accepting horizontal shear, distributed stresses thereby. Because when there's horizontal seismic action of, which generally goes up to 0.25 of direct weight, equivalent I can say, not exactly. So that impacts on those beams and slabs and columns. So columns becomes beams that time, beams become column, and your slab acts as a diaphragm, forcing all these elements to conduct that way, respectively. That makes an essential requirement to tightly bind all bars, and no bar should be displaced during concrete pour or during vibrator application. Vibrator is very important tool, equipment I should say, not tool. Vibrator is very much important and significant equipment for concrete. It's very important in the sense that without this, concrete can't be compacted, and generally it's internal vibrator that is used on concrete, not external one. And because it is used internal one, there's a possibility that it may strike shutters, or it may strike, shutter, or it may strike steel bars many times frequently, and therefore application of vibrator cannot be allowed to everyone. A specific training, though instantly, can be given to everyone, explaining how to use this nozzle, how to use this hose pipe, and what is proper way to apply this. Because generally I have seen ill-trained people, or even those who are trained, sometimes start playing with concrete. Human nature is naughty, and even engineers stand there, they ignore sometimes what people are doing. They try to pull concrete or just to push concrete using vibrator, which is never accepted. Application of vibrator requires should be vertically used. It should not be used with that angle, and there is a limit up to what it used. It should not be used in filled column. Say you fill 1 meter, 2 meter column, and then you use it. That's not acceptable. Only layers it can be used, and layer 2 thickness of layer is confined by length of nozzle. It can't be more than that. And once you start using this, use it, and when bubbles keep on coming out, stop it. Some people go on using it without understanding aftermaths, deterioration of concrete. They don't understand purpose of vibrator. Many people don't understand because they are not explained, and explanation is job of engineer, that they are foreman, engineer's foreman, or engineer's skilled person applied on vibration should know that. So vibrator is very important equipment for concrete compaction, and its training should be given, proper training should be given. It should be freely used without touching any other material. So vibrator must not be allowed to touch on any rebar anytime. No over vibration is accepted. No pulling or pushing of concrete is accepted. No segregation is allowed. All concrete must be vibrated. In case of voids and for voids formation, thorough investigation should be conducted, and then remedial action resorted to. Proper inclusion of concrete spacers. I think I've taken this. Yes. Proper inclusion of concrete spacers, we call them covers, should be made at right locations. Rebars keep intact during pouring activity, that must be kept in mind. Reinforcing bars remain intact during pouring activity, that's very important point. If rebars are replaced or dislocated, then the purpose of rebar is defeated. It's generally been noticed that this item is neglected by engineers as well as other persons, and people don't care for spacers. I've seen many buildings being constructed without even spacers. That's not acceptable. They don't understand meaning of concrete cover, concrete spacers. Because of that, they think it's practice. They don't know real meaning of that. And they don't want to know also, because those people are not engineers. Those people just want to do their business, and they think it's just nothing. I've seen some people using brick bats in place of concrete covers. And also plastic covers are used these days. But I prefer, as an engineer, that we should use only pre-cast covers, our own side cast covers, not even purchase one. Because side cast covers remain the same family as concrete is. And it's very easy to do. Means in just 1 meter by 1 meter frame you make timber. On some plywood you make one board. 1 meter by 1 meter frame, let us say you are casting 50 mm cover. So 50 mm in one frame, you can say 20 blocks each, 3 to 20 by 20, 400 covers you can cast in 1 meter by 1 meter frame. This is 50 mm I'm talking. If you take different thicknesses, you will find different one. Width of cover is okay, fine, but depth should be accurate. Because even 50 mm by 50 mm by 50 mm cast, like 40 by 40 by 40 then cast. But say 50 by 50 by 40 is okay, fine, it's also not bad, because ultimately it will be more stable. So you can say, I don't use plastic covers in foundations, and I've seen problems with plastic covers also, because if these are not of HDP, these are only for LDP, which is useless. If the MDP is little better, but if the HDP is fine. Otherwise you have to use 2 covers in one place. Cover is too serious an issue, which is to be considered accordingly. Precast covers well cured can be used. Plastic covers, if strong enough to bear loads of foundation, rebars, can also be used. People don't understand this. Why do we provide covers? They don't understand really. But engineers can understand. But engineers are not employed on every building. That is really too bad practice. As I'm not here to criticize someone, but it's better if you use covers duly cast on site. Purpose of cover is different. First of all, its purpose is that whatever cover it is, 20 mm, 30 mm, 35 mm, 40 mm, 50 mm, whatever, it helps concrete. That water is not penetrated, moisture is not penetrated, at least to steel itself. If it has to penetrate, it has to travel a distance of cover, clear cover. And also not only water, when of course water is related to corrosion indeed, when I'm talking of fire time, suddenly or unexpectedly or by accident your structure is on fire, that's most important time when we can say value of covers come in. Values of cover come in. Your cover may be in superstructure 30 mm for beam or more, or column may be 40 mm, for slab may be 25 mm. We have to keep in mind that fire is such you can say danger, as a hazard that can cause collapse of whole structure if it impacts on structure adversely, and if within minutes or hours fire tenders don't reach, structure can collapse. It's very important part. More cover is better in fire resistance, firefighting. And of course, it's better for ingress of moisture, and it also is better for finishes. But keep that in mind, and we have to do design accordingly. And moreover, it's not fire alone that would hamper it. Fire, when there is full swing fire, it impacts surface, exposed surfaces to fire. Whatever surface is exposed to fire, that surface heated up. Fire heats up that surface. So that direct contact surface is higher temperature, and this moves in, and internal temperature may be lower. So you can say a surface inverts some portion of that column or beam where fire acts directly, and this becomes higher temperature, and some portion up to inner, some portion maybe 10% of section, 15% of section could be jeopardized by this hazard of fire, and this reduces its resistance. This reduces resistance of that section, of course, in curved form. So that resistance power of section is reduced, and we can say this is a reduced section which cannot work fully, and that portion which is subject to fire has become useless. So either structure has no use, or we have to retrofit that if it can't be continued like that. It's also expensive. How far can you reinstate this? Is the point. So your point remains that why not to think of a time with design to have some more steel somewhere far off covers, or you may call it in core of every member, some type of nominal steel may be added. It's really very interesting point of cover. It leads from one point to another point. It leads to one discussion to other discussion. So we should not underestimate provision of cover. If you underestimate, we underestimate ourselves. So cover is too serious an issue to be considered. Precast covers, well cured, can be used. Plastic precast covers, if strong enough to bear loads of foundations, rebars, can also be used. We have to keep that in mind all time. Now, formwork should be erected based on correct and safe design of preparatory works. Safety is of utmost importance. Safety first criteria should be fully considered and implemented. Formwork is basic of concrete, cast in concrete. Steel is different. Formwork is directly applicable to cause accidents. Formwork is directly applicable to give shape to your concrete or to realize your design. And if formwork cannot perform that formwork is useless. If your formwork permits leakage of your slurry, formwork is useless. If formwork gives rise to plastering mandatory, your formwork is useless. If your formwork cannot give you good appearance of surface, your formwork is useless. If your formwork can't be straight in line, can't be straight in level, can't be controlled 100%, formwork is useless. You may say anything, but formwork should be perfect in all criteria, in all conditions, all considerations. It is important that it should be perfect material, it should be perfectly leveled, it should be perfectly lined, it should be perfectly supported by design system, not by imagined system, not by floppy system. It should be a perfect molding, you can say. Thus we mold steel, or we mold some material in mechanical engineering. We can say our concrete that we are going to produce in a structure is a molding, and for in the formwork is a molding method. It's big part, you can say. Molding is done mechanical or small parts. We are going to cast a material which is big in quantity. It's a mold. Formwork is a mold. Should be erected based on correct and safe designs of preparatory works. Safety is of utmost importance. Safety first criteria should be fully considered and implemented, and particularly for those heavy members like slab, which can cause accident also, where your supporting system can fail, or you provide any wooden material or steel plate or whatever, it can fail, and that can cause it to collapse, leading to loss of life and loss of material. So formwork is very important item, load wise and aesthetic wise. You can't do anything if something wrong happens during formwork, during pouring. So these factors of appearance are very important, factors of safety are very important, factors of fire are very important. You have to keep in mind that. You can't solve everything by method of repairs, because repairs means limited repairs, it doesn't mean everything. You can see columns bulge because of bad formwork or formwork support. You can see slabs formwork collapse or open. You can see wall formwork open during pouring, or it can happen in beams as well. So proper arrangement to keep formwork intact during pouring is very important aspect of formwork design, where we have to use fluid mechanics, fluid pressure, that we know how much we can use. I always give example of weight of concrete. It may be column, it may be beam, it may be slab, it may be whatever. Generally, loads are transferred to formwork from concrete and from people working on that. Temporary loads, preparatory loads, these are transferred to formwork, and formwork transfers to supporting system. And these loads can be calculated very easily. There is no problem in that. Instant calculations, full calculations can be done for slabs, and part calculations can be done for vertical members like columns, because by virtue of time setting, their loads can be affected. It's not big issue. It can be done. Of course, it's not a part of syllabus of engineering, but everything can't be syllabus. We have to think of ourselves and do it. That's why I stress on thinking. Thinking is very important. If you can think extra, you can think extra. Safety is most important. Formwork like design is a part of general engineering. It's not a part of structural engineering, but it can be considered both ways. You have to be calculative, you have to be analytic, not you can say everything can't be based on assumptions or fact, or you can say you can't leave it to circumstances. That's why I should say formwork is very important material, very important preparatory work, because its future, it gives you future of concrete. Sometimes repair cost is too high, we have to keep in mind. Why to spend on repair when we can do better formwork? It depends on your art, your people's skill, your supervision, how can you do better work. In addition to quality control tests, which are slump, air voids, cubes, compressive strength, additional tests should be considered for core tilt. Now it's part of specification somewhere. Core salted out and core tilt for taken out from various locations to make sure that the site conditions match laboratory conditions in cube. So what I say, we have to be very considerate like that. In addition to usual quality control tests such as slump or cubes, compressive strength, additional tests should be considered for core drills, drilling of core, which are already taken out from various locations to make sure that site conditions match laboratory conditions for cube testing purpose. It's an important way. We have to depend on compressive strength of cubes only for purpose of proving that our work is okay, our work is fine. Cube strength declares that work done is according to compliance, according to specification compliance, but fact remains that on site, whatever we do on slabs or on cone or whatever members of concrete, whatever we do, that is in natural conditions. No artificiality is there. Site is exposed to nature, but what we test, that is cube, that is not in natural condition, that remains in tank of water, any other controlled conditions. Those conditions vary, extremely vary to each other. Site conditions is real one and laboratory conditions is controlled one. So both can't represent control conditions, can't represent site conditions. We have to keep in mind. Both are different. Either you keep cubes on site so that it remains same condition as site. When you cure site, when you cure site concrete, you can cure cube also. Either keep that way. So that could be representative of each other. I've done this many times. Though it's not written in codes, but I did it many times because some person, some consultant wanted that intentionally. I never refuted that because there's nothing in this to refute. Codes are not masterpieces and practice is practice. If we want to make sure something, we have to do accordingly. So I did not mind that. Though it is a question of concern, maybe it fails, but engineering is risk. Engineering is full of risks. So we used to do that and it never failed, I'm sure. It never failed. Because over precaution is also not good. Though it is a standard, I agree, but standards are developed by practice. So that practice is acceptable. Nowadays there are provisions in some contracts, some specifications that in addition to cube strength verification, you must have samples from site in forms of core and test them. That's not bad. It's much better than taking cubes, I think. Or you take cubes, keep cubes on site in same conditions as your site is. and then C slab. And I think due to this reason, there have been changes in specifications, there have been changes in your codes, that whatever grade of concrete specified, there's depending on your standard deviation, a formula has been developed that it's plus or minus something in relevance to that grade of concrete. Either should be plus this or minus this. Well, it's okay, fine. It means that site conditions have been included with those formula, with those limits. It should be not more than that or not less than that. Previously we used to say 40 Newton concrete test and to go with 50 Newton laboratory test. It was surprising how you should be happy or say it's 50 Newton, what do you want? It's much more than required one. It's an important one. If that point is covered, it's good one, I think. It's not bad. But we have to analyze that also why it has been done. It's not by happiness that it should be more or less. I just noted those reports during my project career. 40 Newton concrete resulted in 45 Newtons, sometimes 48 Newtons. 35 Newton resulted in 36, 80, 40 Newtons. Or sometimes equivalent to that, equal to that. And there was no question on that. Okay, fine, it's okay. But that's also not correct. Now come on to curing are responsible for life of concrete. Curing is responsible for life of concrete, for strength of concrete, for durability of concrete, and therefore it must be given due care. It must be given due care and control under direct command of a responsible staff. No leniency or worry about cost of water or curing compound or Hessian cloth or polythene sheet to be accommodated. Why worry about that? Curing is a must and must is a must. Without curing, concrete fails. And there is no alternative solution if curing is missed. Tell me if there is some solution and curing is missed, and why it should be missed. Question is that. Why should it be missed? What you save by missing curing. That's the point to be understood. If I spend money on curing, how much it is? If I don't spend that money, how much can I save? And what is solution if curing is missed? And what is loss if curing is not missed? These points are very important. First of all, we should not even think of missing curing because concrete is not self-curing. Curing is, we know disease, that's why we cure. So we know disease is there and we cure it. And it's conventional, this is mandatory. But people sometimes act negligently. They are lazy or they least bother about curing. They do not understand meaning of curing. When you do not understand meaning of curing, for you it is waste of time, waste of water, waste of curing compound, because you do not know theory of concrete. For you it is just wastage of time. I have seen people, very good people, who used to say, I don't like to see water is wasted. It happens. They don't know water is not wasted, but water is used. Curing is no wastage of water. It is use of water. But those people, because they spend money on water and they feel my money has gone in water, it has gone waste. Well, no explanation as such. Curing is curing and it has to be done. No way, no answer, no argument. If you want to do it, do it. And if you don't want to do it, get lost. I don't need you. Simple answer is that. Engineering is very simple and very straightforward. You do it or get lost. No diplomacy in engineering. I don't like any diplomacy in activity of engineering. Get lost, that's it. I either do it or I throw you out. That's it. This is what is engineering definition, in fact, in field. And those who abide by this, I respect them. And don't abide by this, I reject them. Whoever you are not father of engineering. You are not generator of engineering. You are just a follower of engineering, and do it and follow it. Follow specifications, follow procedures, and that's it. And if you don't follow, engineering is not your servant, construction is not your servant. Get lost. That's it. No argument. This project, this building, this structure is going to stay even after your death. Don't forget this. It's going to stay even after the death of your generations. Don't forget this. Be strong and resistant. If you want to control quality, that's an only way. Or if you want to serve only job, I have an answer. Defects observed after striking forms. Whatever defects observed after striking forms should be reported to site person, site engineer, and that must be decided between site engineer and supervising engineer. How to remedy those defects, how to make good those defects. Defects, of course, happen even after total supervision, even after in-depth supervision, continuous supervision. It happens because hundreds of people work on one site, many hundred people, thousands, and many hands change. Your supervision cannot go to everybody. So defects are observed and can be rectified only. No other way. Of course with warnings, but even then, it happens because this is on site. This happens, every site it happens. But it must be detected, it must be kept in view that defects are discovered, not ignored. I have seen people on sites put some Hessian bag on defect. For what, I don't know. Declare, expose clearly this is defect. What's wrong with that? It's not your defect. It's defects by someone caused by negligence. It's not your personal defect. Yes, on my side there can be any defect. What I do? Only way is repair it, that's it. And that's why in advance we agree, at least for repairs of concrete, we shall employ these methods. And that's only purpose that this we agree defects happen, but it should not be all time. It should not be very frequent, because negligence can be done rarely. Negligence is not a part of method statement. We should understand that. We say no horizontal planes of weakness. That formula. As far as practicable, concrete pouring should be planned for monolithic concrete actions. Construction joints should be agreed in advance for an easy execution purpose. Though construction joints are not required, but not always possible to do that. Some construction joints are of course required. It's connection of slab and column, connection of column and beams and slab. These are required. Practice is not to cast columns, frames, beams and slab together. This practice doesn't work. So columns are cast at one time, and then beams the suspended beams and slabs are cast another time. And we consider that all these two stages are monolithic. That's our assumption, though it's not. Similarly in foundations, columns are cast separately, foundations come first, but even then we presume that this is monolithic construction because construction of frame should be monolithic. Sometimes we have to do like that, we have to accept that. And within that acceptance, we can say design is done. Whenever required, soil improvement must be carried out to achieve required safe bearing capacity of soil. Imported desert fill or graded fill required to be used for purpose of limiting liquid limit as well as plasticity index to a minimum value. Liquid limit and plastic limit are to be controlled, and these limits cause problems in soil if soil used like that. Clay soil which contains Montmorillonite, it's called Montmorillonite, kaolite, and many other such expensive materials. Montmorillonite is one of them. It is very, very dangerous material. It's a mineral. It's not soil, it's mineral. But it's expensive, very expensive. If it expands, it swells volume of soils. What you say, soil improvement when is required to replace all soil, that's clay one, or having impurities like Montmorillonite more than tolerance, because when this metal comes in, this mineral comes in contact with water, it swells the soil as whole, and soil is swelled to many volumes, and even then it stays there. So if we can't cure the soil properties, better we take out that portion of soil from below foundations and replace it with good soil or sand. That's only possible. So soil improvement is done for that purpose, and liquid limit is that limit. If you go on increasing percent of water in clay, soil goes on volume increase, and if you decrease that percent of water from soil, a stage comes when this soil starts getting shear strength, below which and above which it's getting into water state, fluid state. Simplest definition of liquid limit is reduce water from mass of soil and test it, and when it comes to water formation, 10%, 12%, 10%. So liquid limit is that limit when you take out water from soil, it will start getting shear strength. Otherwise, it will have no strength, and particularly for clay soil it applies, not for sand soils or other rocks. So we have to consider liquid limit and plasticity index for soils, and if it's not changeable, I mean to say, if we can improve it, fine, or we have to then think of different types of formations. Backfill, you can say, is one activity that makes a lot of difference on future of foundations and must be rightly conducted. It has been observed that site engineers try to neglect its supervision and save project time by filling thicker layers of fill. It's not a good practice. Backfill should be conducted in good compliance, should be carried out in good compliance to agreed specifications to achieve 95 to 98% field density. General fill can be compacted to 90%. Construction, see, where I say 95 to 98% FTD, this is backfill where structural load work. That's 95 to 98%. 98% actual one, it may be more, where your structural loading comes in, and where I say in certain cases 95% is also applicable. But when there is general fill, you can say like landscape, like drainage line, where loading is not that heavy, you can say 90% FD may be accepted. But if engineered soil, graded soil in various places, in foundations and around foundations, there is requirement of 98% and must be. It can even be more, achieved more, as seen more 100% in many cases. Depends on what fill you are using, what sample is sent to laboratory for testing, what was composition of that sample, and maybe batch you filled in is more stronger than that. So we compare it to that one only when it's called FTD. Percentage means percentage of achieved by backfill density achieved by that sample. And we compare it to this sample. So engineered fill is more important than else. Engineered fill is better also. You must understand this point very well. Engineered fill and that fill and this fill from all aspects of life. Oh. garden place. Okay, let me see. What is this? Just trying to find soil. Just trying to find the soil. I forget what to do. Will ever find that? Inside the soil report. I need to ever find it. That's the problem. Wasting time. I waste time of others. It is in some directory. What's that? It's not correct. I used many times. Management documents it is? No, it should be. It's facilities maybe. No, it can't be in this. Oh no, it can't be in this. No way. Well, when I need, I don't find it. What's the problem? I forget all that. I'm wasting time. Why I'm wasting time? I don't know. It is very important document. It's very important document. That's okay. But where it is? Same consultancy. Time soil. Where is soil? This is shame on me. It's really very shameful. I can't find that. My memory has gone, I think. Nothing. Why? Submission records, career, blogs, books. Yes, now it's starting in here. Nonsense. Wasting time. I'll leave it here. Leave it later on. We'll see. I forget otherwise. And the documents and the expenses. Resource person talk. Oh, I got it. Yes, soil report. See, yes. At least I saved it. Okay, no problem. Something's better than nothing. It's very long report. It's very long report. It can't be taken up immediately, but it's part of something. I just browse it and see. Let people see what I'm showing to them. Let people see. Let them see what I'm actually trying to browse on this. This is from some laboratory. This is a practical one. It's not from lecturer or no professor. It's from practical world. It's giving so much information in this. I could not complete it last time. I'll do it again, but it's a very important one because there are so many reports, so many side reports in this report itself. No completely adequate egress theory exists for calculating ultimate capacity of footings. Satisfactory approximate solutions have been obtained in basis of vigorous simplification assumptions. That's Tarjagi 1948 and Mayor of 1955 demonstrated that bearing capacity of footings is derived from two sources: frictional resistance due to weight of sand below level of footing and a frictional resistance due to weight of surrounding surcharge of backfill. Unit weight of sand is in itself not an important variable in determination of bearing capacity of a footing. However, if sand is located below free water surface, only its submerged weight is effective in producing friction, and therefore position of water table is with outstanding practical importance in establishing bearing capacity of footing on sand, and bearing capacity is also greatly influenced by relative density. Bearing solutions tried to show that ultimate bearing capacity of footings on sand depends mainly on four variables: position of water table, relative density of sand, width of footing and depth of surcharge surrounding footing. A relationship between n value from that standard penetration test and bearing capacity was established. However, this relation is approximate. Choice of particular type of foundation depends upon character of soil, presence of groundwater at that site, magnitude of imposed loads, and project characteristics. One has to choose type of foundation which is not merely safe but also economical. For a particular case, no information about imposed load is available. Water table was not encountered in the OL. This is a report only. This is conclusion, recommendations, and different types of reports are available for different types of foundations. Example, allowable bearing capacity for shallow foundations. Allowable bearing pressure was determined for foundation ground as specified above using practical experience and results obtained from field standard penetration tests and empirical equations developed by Tajagi and Pack. Made of and modified by Bowles, and taking into consideration a safety factor of 3 against shear failure of soil. Accordingly, that allowable bearing pressure values recommended to be used for design of footings with different widths and at different depths based on 25 mm settlement are presented. So this is test report results. I'm just trying to show you what is about. What about this, just trying to show you certain report that I've shown past as well. Just trying to show you, you can say here. My God, it is gone again, same way, like this, this is a different, at different depths and for different widths. So some we'll discuss later on. Of course, I've discussed already, but we'll discuss this later on better. Let me come back to previous one. Sorry. Like this, there are so many reports. Long file, as I said. It would even take time for this to be in that mode. Just now you can see. Move on to this for various. I'm just trying to show you what this contains in. As I say, structure fill I said now before. This was backfill material and compaction criteria, and now structure fill. In case structure fill is under foundations required, then metal to be used shall be free of organic material, organic matter or other deleterious substances. Chloride content shall be less than 1%, and sulfate content 5%. Well graded granular mix with no particles larger than 75 mm and at least 80% of material smaller than 19 mm in size. This structural fill. Metal passing CO200 shall not be less than or equal to 15%. पता नहीं अब खुला हुआ है फिर भी बजा रहा है, कौन बजा रहा है? पता नहीं यार, माली और कौन होगा यार, चक्कर है इसका. Structural fill. You can see it's a general fill then. This is borrow sources. Like this. माली है. नहीं अभी तो निकाल से. So it is that. Alright, take it later on.